Hello everybody, welcome to that session. Just a few words again to myself. My name is Andreas. I'm based in Switzerland, working for SAP's Global Center of Excellence for Analytics, in which I'm an expert for predictive analytics. And in today's sessions, I want to cover a number of things. I want to very briefly introduce the area of predictive analytics, but really focusing on use cases and what kind of areas of predictive analytics can be used to implement various different use cases. I've brought along a couple of slides on customers that have that solution in production, in action, and also I would like to show a number of demos using that tool, implementing or showing how to create models that are very typically used by our customers. And everything that I will be showing today live in our tool, you would actually be able to carry out yourself later after the webinar, where you may know we have a trial version of our tool that you can use yourself. You can download it free of charge. And the data that I'll be using, we're offering as a download, and we have tutorials that guide you through the demonstration exactly the way that I'm doing it here. And now, basically introducing the area of predictive analytics very briefly. You might have seen that slide. I find this super helpful. So on that slide, you might have seen it before. We see how the maturity of an analytics environment is growing, providing more and more value over time. And we all know we start with raw data. We have to put the data together. We have to clean it. We have to take care of the data quality. We have to use that data. We have to put it into processes. We have to make it available for analysis, often formatted reporting, sometimes agile reporting. But no matter how agile or interactive your environment is to analyze the data, there will always be a point, some kind of limit as to what you can find yourself as a business user in that data. Of course, it can get extremely complex. And that is exactly the point where predictive analytics kicks in, where we can connect to existing environments, could be data warehouses that we are connecting to, leveraging the data you already have. So all the effort you have already put in, we can leverage in the area of predictive analytics, where now we can use them, let's say, clever mathematical or statistics to find specific patterns in your historic data and find these patterns or trends and try to continue that trend into the future, essentially predicting or estimating what is likely to happen in the future. There could be one predictive model, there could be hundreds, it could be thousands of predictive models, giving you a lot more insight into your business, into your customers, into your products. And now with that insight, giving you the chance to take action with that additional information, that you can really leverage the historic data to shape the future, I like to call it. So that is predictive analytics. And to make it a little more realistic or pragmatic, I think this could be a helpful second introduction, where very often predictive analytics is used to optimize a resource which is not available without end. So most of the resources we're working with are limited. It could be your time, it could be your finances, it could be anything, where predictive analytics can help you make the best of the resources that you have. And often that starts with an aim. That could be a strategic goal of your company. What is your company working towards? And what are actions that help support that aim that your company is aiming to achieve? And these actions that you're undertaking typically will have some bottleneck. And this is where predictive comes in handy, I explained, to make best use of it. And to have it as a real, very common case, let's say you want to optimize a marketing campaign. And here, the aim you might be having, or many of our customers have, is to improve market share. In that case, by growing revenue. All of us would like to do that. And then the action that will drive to increase the market share or the revenue could be to increase the number of successful cross-sales. So existing customers, they'll give them ideas about further products that they're likely to like. And there, that bottleneck very often can be the marketing pressure that a customer is likely to accept. So you might define that for a typical customer, you only want to get in touch twice a month, maybe by email, maybe by telephone, maybe other channels. But very often, if you send too much information, people get overloaded, maybe annoyed. If you don't send enough information, no, people think you don't care. So in this case, imagine you only want to have 2 contacts a month, which is that bottleneck. So once you have a contact with a customer, once you send an email, which message do you want to transfer? Which product, for example, would you like to promote? And here, that prediction that we produce, it could be done for 1 product, it could be done for 100 products, then it's fed into the marketing process, where now, of course, the campaign will be optimized. So you may want to recommend a product where the customer is most likely to be interested, or where the estimated profit for a product might be highest if the customer is agreeing to it. And in such a process, typically we have different personas. On one side, we have the data analyst who is creating these predictive models, and we have the marketeer who's benefiting from that insight. So it doesn't have to be the same person in the business department creating these predictive models. Very often it can be a data analyst, it could be a subject matter expert, somebody who's got a good flair for data, but very important, it does not have to be a data scientist. So data science skills are very rare, and we have an environment that will show you where we can create these models highly automated, where in that case a data analyst can really focus on the kind of business question you would like to optimize. Or a second example here from manufacturing. Imagine you want to increase your customer satisfaction. And one way to achieve that could be that when an order comes in, that you are ready to deliver. That when a certain product is ordered of a certain quantity, that ideally you would like to have the product in stock that you can deliver immediately. And here that bottleneck could be the space in the warehouse, the cost to produce products, or the capital that is tied up in the warehouse of products that are not selling or not selling as quickly as you would like. And with that, predictive analytics could estimate likely demand for different products for the next month, the month after, but the next year, whatever time intervals make sense for your industry. And again, the same principle, a data analyst, who might be the same analyst that is also helping along on the marketing side, can create these insights and deliver them to the processes where they are needed. In that case, it could be the production manager finding that further information. And that's already 2 different use cases, but use cases can be extremely diverse. And I believe in every industry, in every department, predictive analytics can be used to help the company to profit. And extremely often companies are starting their journey with predictive analytics in sales and marketing, such as what are the products that a customer is likely to be interested in. But also think of the opposite way. What is the risk of losing an existing customer, where if you know that information in advance, that a customer is likely to move to the competition, if you know that early enough, you can try to take action and try to then actually consider next best actions. What can you do to strengthen that relationship before the customer has actually left you? Another area is can be clustering or customer segmentation, where the customers that you have, now all of them are of course different, but others are more similar to each other than others. And segmentation can help to find certain groups of customers that are fairly similar without you necessarily knowing upfront what is it that makes them similar. And the segmentation can identify these groups, which you could then handle specifically or individually. Maybe you run different marketing campaigns for each segment that was found, or maybe different sales approaches, different sales team may want to handle these different customers because they have different requirements. Then moving to operations, where here we could think of predictive maintenance. So if you're manufacturing, what is the risk of a machine having a failure, or at least showing unwanted behavior, which could be vibration or other things you'd like to avoid. The earlier you know that, the better, of course, you can intervene. Something else that's very common is demand optimization, really knowing in advance which products are likely to sell in which quantities. I showed it earlier in the example on optimizing scarce resources. And most companies don't just have one or two products. It could be dozens. It could be tens of thousands. So we have the ability to mass produce models at ease. We don't have to do everything manually, but it scales with the demand that you might be having. Or if we think of quality management, this could go in the area of while you have produced an item, or it might be semi-produced, it is not completed yet. Here you could use predictive analytics to estimate how likely is it that if I complete this product, will it be of good or bad quality? If you think it's likely to be of bad quality, you can decide what to do. Maybe you want to discard the product, not invest any more money into that product just to throw it away later. But at the same time, predictive analytics can also tell you the reasons or drivers, patterns that lead to a certain behavior. So in that case, predictive analytics could give you indications what kind of details lead to bad product quality. Maybe it is a certain sensor in the machine, maybe it's a certain raw material from a specific supplier, that if you know that information, you can investigate and find out what you can do. Of course, try to avoid these problematic areas to actually increase product quality. Or now moving to fraud and risk, and I'm just picking out a few where in fraud, clearly we're thinking very often in insurance cases where fraudulent claims can be made, where with predictive analytics, the fraud, well, the insurance case, the claim can come in, it can be analyzed for any suspicious behavior, and it can be flagged for internal audit team to have a closer look if needed. It can also go into the area of compliance issues. If you think of your own internal IT systems or security access, where it can happen that people by mistake are given too many access rights towards certain activities in their own system. They might know it, they might not know it, but based on cases that you had seen in the past, you can find a predictive model trying to identify further employees who might have been given too many access rights. And again, you can look into their access settings and adjust if needed. If we look into finance and HR, very, very common is cash flow forecasting, where it is all about trying to optimize your finances. So the better you know how much finances are likely to come in tomorrow, the next week, the next month, the more accurate your insight to that, the better you can adjust your financial planning, reducing financing costs, having to take smaller loans potentially, or take advantage of different payment terms of your own suppliers, if you know better how much in cash you're likely to have in the future. Or also budgeting, where it is about really being more accurate in your planning application, where not all planning applications take predictive insight into account when trying to estimate the next planning cycle. That could be internal numbers, that could be costs, again, it could be revenue, but where here predictive analytics could produce more accurate plan values, which can still be fed into your existing planning application, where employees can still look into the numbers, they can adjust if needed, but hopefully the required adjustments should be smaller. Or then the last area, we have the other sectors, where literally across any kind of industry, as we call it, there are so many use cases. If we think of healthcare, just to pick one example that I was involved in, where it could go into the area of hospitals, where of course there's a very high need or desire to prevent patients from getting new infections while in hospital. You could use predictive analytics for new patients trying to assess the risk of these people being infected by a certain disease. If you know that in advance, maybe on certain patients you have a closer eye or be even more careful than you would be anyway. But also here, we can identify the patterns that can lead to infections, also trying to avoid these in the first place. Public sector could be security related, or big data and IoT could be another insurance case where telematic data can be leveraged. So think of the little boxes that are now part of some insurance contracts, which are embedded or placed into your car, that measures your driving pattern. And this data could be used to assess sort of, let's say, your driving style or the risk of having an accident in future, which then the insurance company will be very keen on using for predictions on, for example, the risk of you having an accident. So many different use cases, and it's really hard to focus down on a few. But what we're doing here with our tool, we call it SAP Business Objects Predictive Analytics. We believe it is very special, where we can create these predictive models without you having to be that data scientist, where we have a whole comprehensive framework that does not do any assumptions about the data that you're using, but where now you can focus on the business question you want to solve, leading to results in a very short time frame. So typically it can be days, not weeks. It can be even a lot faster, depending on what you're working with, but also to set the expectation right. And we do need some kind of data source to connect to. So if today you would like to leverage predictive analytics on 5, 6 different sources, still, some effort needs to be put in to connect these different pieces, whether physical or semantic. But once we have the data, of course, then we work with that automated approach. And this automated approach also means that we can produce these thousands of models. It is not just one model that an expert produces, and of course also has to maintain. So if we think of a customer analytics with affinity of a person to be likely interested in a product, the model that is created today is accurate today, but customers' behavior will change over time. And if the behavior of your customers is changing as it does, then the predictive model isn't as good anymore as it was on the first day, because it describes a situation which doesn't exist anymore as such, which means model need to be monitored, need to be retrained if needed, so that we have a component that is doing that automatically. I won't go into it today too detailed. Just to mention the name, we call it the factory, which takes these models and monitors them at a scale. And of course, just having this insight, having these predictive values somewhere stored in a silo doesn't really improve your business. It only changes the way you work if you really feed that information back into a process. You bring it where people need it, where people interact. That could be, for example, that marketing process where now with that information from the inside, you know which product to recommend. And these use cases we've been speaking about, we cover with a number of core data mining functions we have embedded in our tool. And the naming, I believe, can be almost sort of exchanged. It could be machine learning, artificial intelligence is very close to it. We very often call it predictive analytics, but they are extremely similar areas. So I believe the terms, in most cases, really can be interchanged. And the core functionalities here that most likely you will need, we have listed here, and I'll go through them one by one before drilling deeper into a few. Starting with the classification, where here it is all about trying to predict a yes-no event. Will something happen or will it not happen? So that could be trying to predict, is your customer likely to churn or not? Or is an invoice likely to be fraudulent or not? It could be preventive maintenance. Is the machine likely to show strange behavior or not? So any kind of decision you can put into a yes-no classification goes into that classification. Then the second area here is regression, where we estimate a numerical value. It's not a percentage. It can be sort of, let's say, any number. Very often it can be sales quantities, as you see on the slide here. how many products is a customer likely to buy next quarter. So giving you an idea about the strength of the relationship you have with that customer. But it could be totally different information. It could be for a retailer. Imagine you have, you plan to open a new store. You have 2 or 3 locations available. So where would you like to open your store? Then a regression can be used to estimate how much revenue or profit you're likely to make in each of these locations based on different criteria. Where is it? How close is it to a train line? How well is it connected to public transport? How is parking? How far is the next competition to that potential store? That regression will give you an estimate of how much revenue you're likely to make. Or a regression could even be used in the area of data quality. Imagine you're a business-to-consumer company. You store detail about your end users. For some people, you might know their salary. For others, you might not. Here, a regression can be used to estimate the salary or the household income for people who you don't yet have that information. The third area here is segmentation and clustering, where we try to identify these groups of similar things, whether it's customers, whether it's products, it doesn't matter. We find items that somehow similar, that you can treat them in a certain common way. Or if we look at forecasting, we look into the area of, let's say, numerical values that appear over time in regular intervals. So it could be daily revenues, it could be monthly revenues, it could be how many people are calling a call center day by day. So that is forecasting. And then recommendations is very much where you have, let's say, hundreds, thousands of products, where we try to use your sales history to come up with product recommendations. Like you know it on many, many websites, you go to Amazon, you look at a product, it will show you recommendations for other products you might also be interested in. And now going deeper into the classification, where I'll show a brief example here, coming back to the case where we optimize the telephone campaign, where you have many, many contacts that you could possibly call. But of course, time is limited. We have a restriction here, a bottleneck. So who should you call first? Who should you invest your time on? The principle is you look at who did already buy that product in the past. These are the ones that are marked in green. Of course, that gives you 2 clear groups, people who did and who didn't buy. And now predictive analytics comes in trying to separate these two with a classification rule. Once the rule is found, you can apply it on the people that you have. And here, looking at the history, we take in all the information into account that is available for these people, age, gender. The more you have, the better buying behavior, and it will separate these two as good as it can. And looking at the past, it will never do it perfectly. If it's done a perfect, 100% accurate separation, most likely something went wrong. They're predictions, so there's a risk of getting something wrong. But once we have that rule, we apply it on the people that we haven't called yet, and now per person, we know their likelihood of being interested, and very simple, you sort it, of course, you know who to call first. And that's a principle for classification, no matter whether you do it for marketing analysis or for very different use cases. It could be churn analysis, it could be preventive maintenance. And that I'd like to show you now in that tool I've been speaking about, Business Objects Predictive Analytics. Think of me now as an analyst, somebody who's got a flair for data, wants to create a new predictive model for the marketing department. So I'm working in the automated way. If you're an expert, we also have an expert environment. In that case, today, though, I'm really sticking to automated. Where you can see the core functionalities very much as I'd introduced them, where now I go into a classification. And the first step is to connect to the history of the data that you want to learn from. That could be it could be a database, it could be HANA, or very pragmatic, it could be a flat file, as I'm doing here now, where in this data set that you can also download, I mentioned all of this you'll be able to do yourself afterwards, where in this data set I see people that I have already called, and that's actually real data set from the real world. It's a Portuguese bank that was kind enough to share information about people that they did actually call. Each row is a person that was contacted. We have some information about these people. their age, whether they have a loan, for example, or at the end, did or did they not buy the product that was being promoted, which in this case was like a savings product, investment product. So that's history. And now all you need to do is almost tell the tool what to describe. You're not really exposed to algorithms or anything else. There are many things you can fine-tune, but the idea is to really focus on the business question you want to solve. For classification, you need a target variable, the purchase. There's no decision that we had. On the left, you have as much information as possible. This is just a really short example. It could be hundreds, thousands of columns. The row ID, I'm just excluding. That won't provide any value. And with that, I can simply hit a trigger. It's very much like an automatic camera. You decide what kind of photo you like. You press a button, and all the settings, of course, it is done automatically, as it was done here. It is giving us some information about the quality of the predictive model that was being produced. Without going into too much detail now, it's telling us that 14 of the columns were being used, that it has a good possibility to describe or to find the people who will buy. It's got a value of 0.5. Number 1 would be perfect, 0 would be no added value whatsoever. And it also found the model to be robust. That's telling us a predictive confidence with 0.99. And that could already be a model you could put into production, but most likely, especially on the first attempt, you want to better understand the model, you want to understand its findings, its value. And here, in that chart, that gain chart, we can see the quality of that model. On the x-axis, we see all the people from the data set. And on the y-axis, we see only the people who did actually buy the product, which of course are the ones that we want to identify. And ideally, I would like to sort people here on the x-axis, but at the very left, I have the people that I believe are likely to buy. These are the ones that I should be calling. And to explain it quite quickly, if you were working randomly, so no predictive insight whatsoever, imagine you pick 10% of the people from your history. That means you will also find 10% of the people who will buy the product. That is a red line. The more, the better, but nothing optimized. If you were a wizard, you would know exactly in advance who will or will not buy. There would be the green line, where every person you call or you identify is a purchaser, is a buyer, and you can just stop. At some point, you have achieved everything. Reality, however, is in between, as you see in that blue line, where this blue line describes what our model is predicting. And it's scored for every person the likelihood of being interested. It's sorted. Thank you. Where I was just explaining the value that our model is delivering, which we see as that blue curve here. And imagine now we were just contacting 5% of the people that we have available. If I go up on the blue line, you can see that with these 5% of the people, we can achieve 22% of the people actually bought the product. So we optimized our campaign by the factor of 4, or even above 4 in that case. So that is the value provided by the model. And the question was now which attributes were actually selected, that we can see in here. You can look into it, you don't have to. Where now we see the 14 columns that were chosen. At the top, of course, the most important one. Anything that was irrelevant was removed, which is also why we can work with tens of thousands of columns even, where we just remove the ones that add no value, but put it into the tool, maybe there's a chance it can help. And here we can also drill into these columns to better understand how they affect the model. The column P outcome here stands for previous outcome. It tells me how did that person behave in the previous marketing campaign that I had already run. If you click into that column, you see now the values available within that column. And so to simply put, the further you are on the left, the more likely it is the person is interested. So where the last campaign was already a success, chances are they'll be interested again. If, however, maybe we have never contacted them, unknown, there's a chance they will not be interested. And we can do that for all these columns, even for numerical ones, where we had an age column where we know the person's age, and where the model was able to identify ranges of ages that showed similar behavior. People over 58 very high chance of being interested in the product. And then the second most interested group were the younger customers, aged between 18 and 30. So the other end of the age spectrum, probably interested for very different reasons. You can speculate, I can speculate. People over 58, maybe they've paid off their mortgage, they have some finances available. People aged 18 to 30, maybe they haven't purchased a house yet, maybe they have had their first job, some first savings, and now it makes sense to invest that money. So here, this is the way where you can really understand what is driving that behavior. Which behavior would you like to enforce? Which kind of behavior or pattern would you like to avoid? And now on that screen where I can sort of simulate through that model, where I now see the 14 columns that were selected, the tool can pre-populate the most common value for the column, so finding like a super average customer, John Doe, where for this person I have a likelihood of 5% of being interested. And this is just a screen where you can try to better understand the working of the model. This is not how you would score your thousands of millions of customers in the production. But, we saw that if the previous campaign was successful and if the person was, for example, age 60, the probability of success should be higher. I have it recalculated, and we see that the probability suddenly is 53%. So compared to the very average person here, I only need to pick up the phone twice with a 50% of chance instead of 20 times. I've optimized my bottleneck. And the model that we have here, it could mass produce these scores and write them into your CRM system, or you can produce logic program code that you can use in real time. The moment person calls your call center, it could produce scores for that person that helps the call agent to structure or drive the conversation. But of course, I can also now score information in batch. And here you would now score people you haven't called just yet. I just have the same data set, so I apply it on the same people. Again, just a flat file. You can say that you're interested in the probabilities for these people, and I could write it into the system or again, just into a flat file. Just call it probable. And with that, the logic that it had already produced is being applied. It's writing that data where I needed it. I can have a preview of that information where it shows by default the first 100 rows from that output, not the best 100 people. So let's make it a bit bigger. I can sort it on the column which contains the probability, where here we see people actually with a similar probability of 53% of chance of being successful. So this could be the list for your marketing campaign, these people you really want to contact. And with that, I'd like to go back to the slides, sort of leaving the classification, but briefly mentioning customers using that technology, and I'll try to keep it brief because we have that delay. But one customer of ours I can speak about is mBank, which is a banking group based in Poland, in Warsaw, actually Poland's first online bank. So data for them is absolutely important because they don't really have the permanent face-to-face interaction with customers. And here, for instance, they can use the card transactions that their customers have for marketing campaigns. So really understanding their client, and they use that information for product recommendations, but not just their own products, but they build up a network with partner organizations that provide totally different products. There could be consumer electronics, it could be restaurant deals, where they provide them these kind of products, such as maybe a TV, often bundled together with a standard banking product. So here, something that sets mBank totally apart from the competition, by building up a network and providing information beyond pure banking, really bringing information that is relevant to the people. Another customer is Covenant Transport, very different use case, but still a classification, where in their industry, it's a haulage company in the US, they have a challenge to hire and keep their truck drivers. And now they use predictive analytics in that classification to predict what is the likelihood or risk of losing a driver, but also trying to identify the pattern or the reasons why the drivers are quitting their jobs, trying to work against that. Just the way how we had interpreted the model, how we found certain information that was driving a certain behavior. Now Covenant is aware of that. They can try to avoid these areas, to keep people longer in employment. And the return on investment, that they achieved within the first half year, so it very, very quickly paid for itself. Then going deeper into the forecasting, so we have like time series. And to also explain that quite quickly, imagine we have monthly sales numbers or sales quantities in demand. We have a certain history over time, where in that case, now we have a sort of nice, very steady behavior where we're selling more over and over again. Clear trend, so prediction is very, very easy to do, of course. But reality is different, is more complex. Very often there are seasonal patterns, where here we can see spikes during the middle of the year, which we can also identify purely knowing, let's say, the month and the historic demand. We can predict what is likely to happen in the next year on a monthly basis. But real reality still is even more complex, where it's there's a lot more variance in these numbers. They're ups and downs. They're not as regular as I've shown so far, but also these patterns we can predict, especially if we can take additional information into account. Think of weather information, think of promotions you are running that will have a huge impact on this number. And what I speak here now about demand, it could be cash flow, it could be people who call your call center, it could be all sorts of things. It is all the same concept. And also that I would like to show in a brief demo. And yeah, so time series analysis. And here I have another data set, again from the real world, very much a demand forecast. You could think of it as a demand forecast, where in many cities around the world now, we have that concept where you can hire bicycles very briefly for 1 or 2 hours. You can cycle for a kilometer or two, you just drop it off elsewhere. And that exists, for example, in London. And London is sharing the number of bicycles that were rented out each day. Here's history for the last couple of years, where we have a day and we have the number that we're interested in. And only with that information we can already do a first forecast, where now the screen is slightly different, where I realize there's time information. There was only one column available with the hires, and all I need to do is again in that case tell it how many days to forecast, let's say 10. And now it is looking at that historic data, it's looking for a trend, is looking for different types of seasonality. Could be weekly, it could be monthly, it could be yearly, it could be annual, and trying lots of different statistical ways, trying to describe that past, and then writes that into the future, which will give me a forecast in a second, where we can see the whole history, but also the prediction that the tool has made. And such a time series is described with a different measure. It's called a MAPE, median average percentage error. So it tells us on average by how many percent were we wrong. Here we were wrong by about 19.7%. And depending on the use case or situation, this could be really, really good, or maybe there could be room for improvement. And we'll try to improve it in a second. But now to show the actual forecast that was being produced, where in that screen here, I'll just zoom in a little, where in green we see the actual value, and in blue we see the forecast that we produced. And the model was also applied on the historic data that we of course know, but then the 10 days that I asked for we see on the right hand side here, where the shaded blue area is a prediction interval, and the smaller that area, the more confident we are in the prediction. And so we can see that there's clearly a weekly pattern, for example, every blue bump is a week. So it sort of tries to follow the real values, but it's not extremely close, we have to say. Especially some numbers that are marked with a red square. These are numbers where actual and prediction are far apart. We call them outliers. So something special happened on these days. And that something special could be all sorts of things. In this case, it could be the weather, it could be a tube strike, it could be the Olympic Games in town in London that is included in that history. And we can now try to describe the bigger context through additional columns, which, of course, I have already done. So I have a second data set. It's called extended, where here now I can still see my day and the number of hires that I had, but there's a lot more information, for example, telling me now the weather data, the mean temperature, min or max, humidity, so how much did the temperature change during the day with the Olympics in town, whatever you can think of, you can try to put it in here. And a quick look at the numbers, we can see now these additional columns with the information I just described. And that's a very typical process in order to try to improve a prediction, that you try to find additional data that helps the forecast, that will help the model. And here again, I keep all the information in, and I try to forecast 10 days again. There's some warnings about the data structure, which we can ignore. And now it is looking at all these columns. It's identifying what column had an impact, will improve the model, how will it improve the model. It is going through all these combinations. And this one now might take a second longer because there's more data to analyze. That part is so now we see how the model has improved. The MAPE dropped from, I think it was about 18 or 19% down to 13%, which we should also see when we look at the actual forecast. We're in here now. Well, the colors changed, but the principle is the same. Where green is still the actual values that we had, and now our forecast here we have in red, where you can see how the model is a lot more close to the actual values in how it happened. And this is now possible because these extra columns, that extra information was available, and we can also see on which columns were being selected here to be more accurate. The most important here was information whether it was a working day or not a working day. That's what's meant with holiday, but also the temperature here, the mean temperature, played a very important part. And with that, back to the presentation. And well, the customer that I can mention, Ems Grilltag, they use that to improve their production planning, to know better so how many quantities to produce, not to have too many or not too much, or not too few in stock. But I won't mention others, or Cisco, for example. An area I meant to cover was recommendations. I'll leave it out today, but it is about the area of if you are a company selling, let's say, hundreds of thousands of products, and how you can derive recommendations for these. So not just one or two predictive models, but out of thousands of products, try to identify which products to individually recommend to your customers. And if you like to see how that could be done, it is part of the tutorials that we will be sharing. So you can follow all that yourself. It's a data set, again, from the real world, where people listen to music. It's about 700,000 combinations of people listening to a certain band. You know how often they listen to that band. So you could use that data set to make your own little sort of music recommendation engine, or maybe even find music, so to say, products that you yourself might be interested in. With that, I hope I could give an introduction to the many, many different use cases that there are for predictive analytics and how companies can benefit from that. That we like the way we do it highly automated, that it means you don't have to be that data scientist. If you are, even better, but it can free up some of your time if you're a data scientist. That we do that by scaling. We have a factory component that can maintain these models, keep them up to date, and bring them back into the processes where you need that insight to actually change the way you're working, to optimize your processes. And Hopefully this got you interested in predictive analytics as a topic, hopefully also as a tool that we're providing here. I mentioned initially that there is a trial where you can download the software, which gives you that installation exactly of the tool as I was using it. You can use it for 30 days. And to help you along in the first steps, there are tutorials. You see the link on screen, but we will share the slides so you don't have to write it down, where you can go through that purchasing affinity. Is a customer interested in a product or not? Where we can do the demand forecast that I showed, but also in addition that product recommendation I didn't have time for now today, which in a way is a link analysis, so a combination of products and customers, where you can find more insight. And with that, thank you very much.